Alright, for this subtopic 3.5, so what happened is that we're going to have a look at how to solve for equations that have both type of equation that we have seen before. So it's going to involve both logs and also exponent. And this will be the idea that we're going to apply. So if you have log of bm equal log of bn, okay, so if you notice they are exactly the same. So this is log base b, so this is log base b as well. So the only difference is going to be function that goes after the base. So if this is actually equal, so then it must be the case that m is equal n. For example, so let's say if I have log of let's say it's going to be log of 10, so log of base 10. So log of base 10 x is going to equal log of log of 2. So what happened is that here this is the same. Automatically we know that x is going to equal the value of 2, okay, because if you get rid of the log, so they are going to be exactly the same, okay. So that is going to be the example of the first idea that we're going to apply. And the second idea is going to concern about index. When you have b to the power of m, so basically you have the same base. Again, the base have to be the same, then only they are comparable. Then only you can apply this. So base, so I have base b raised to the power of m and base b raised to the power of n. Then we can conclude that the value of m and n, they are the same. For example, let's say if I have 2 to the power of x is equal 2 to the power of 3. And therefore here we can make a conclusion that the value of x that is going to equal 3. However, again, I would like to remind you, so the fact that the base must be the same, then only you can apply this assumption. Okay, so I'm going to show you 6 examples right here. And again, like if you are already well versed with this topic, you have learned this during your STPM or diploma or metrics, just don't bother watching the whole video. So just simply take the question, so try to do it on your own and compare with the solution that I show in the video or in the notes itself that I've given to you in the PDF form. Okay, so I'm going to start with the first one, which is log 2x is equal 5. And I would like to be clear about this with you. So when the question said solve that, meaning you have to find the value of the variable. So then put over here, solve means find value of variable, right? For example, let's say if I have log 2x, what is my variable? So my variable is going to be x, okay? So for this case, what I'm going to do is I have log 2x, log x base 2 equal 5, and I have to find what is going to be the value of x. The first thing that I want you to come in mind is that the fact that when we wanted to find x has to be by itself. So I have to get rid of the log 2. Okay, how do I get rid of log 2? So remember that the form of log and index, they are interchangeable. For example, so let's say if I have log of AB equals C, so we have seen this before, okay? So what happened is that my base is A for this case. When I change this to index form, I can write that B is going to equal A to the power of C. So previously A is the base of the logarithm, but when I change it into index form, so A is going to the base of the index. So this is what I'm going to use. So I'm going to get rid of the log. How do I do that? So I'm going to make it into index form. So this is going to be, so log of 2x equal 5. So I'm going to have x is going to equal 2 to the power of 5. And if you use your calculator, so you'll know that 2 to the power of 5, that is going to equal 32. So basically, that is going to be our solution. So I need to find the value of x, and I figure out that x is going to equal 32. That's it. We're done. Okay. And for the case of b, so it's not going to be as simple as what we have seen before, because here what happened is that I have 3 different log. But the good news is that all of them already has the same base. So this is log E, and log E. So therefore, we can do the operation right away. So what I'm going to do is I'm going to rearrange them. Okay, so whether you can leave it in this form or you can actually put them on one side. So that is applicable as well. So for example, let's say I'm going to write that this is going to equal log of x plus 2. If I move everything to the other side, I'm going to have minus log of 2 and minus log of x minus 10 So that is going to equal 0. So even if you don't want to move it, that's fine. So you're still going to get the same solution. So this is one of the idea that you can do. Right, so now that because they already have the same base, so I don't have to bother with that anymore. And when I wanted to simplify this, so I noticed that I don't have any constant at the front. So this is already 1, this is already 1, this is already 1. So I don't have to move them as the power. So next what I'm going to do is I'm going to put them together in terms of in terms of simplifying into only one log term. So the positive is going to go up. So I'm going to have x plus 2 at the top. And at the bottom, I'm going to have 2 multiplied by x minus 10. Remember, whatever that goes at the bottom, these are two different terms. So you have to multiply them both. And this is going to equal 0. So I'm going to have to add another page for this. Okay, and then what I'm going to do next is I'm going to get rid of the log because I wanted to get whatever in here because I have to obtain the x. And in order to obtain the x, I have to get rid of the log. And remember what is ln? Ln is actually log to the base of e. Okay, so now I'm going to change it into index form. So when I change it to index form, so I'm going to have x plus 2 over 2 multiplied by x minus 10. So here my base is going to be e. When I move e to the other side, so I'm going to end up with e to the power of 0. So that is me getting rid of the ln. So it becomes e to the power of 0 when I change it to index form. So let me put over here. So what I did is I changed to index form. So basically I have log of e and the function f of x. So I'm going to say that this whole function over here is f of x. So equals 0. So basically my function f of x is actually going to equal e to the power of 0. So that is what I apply over here. And the good news is that e to the power of 0, anything raised to the power of 0, that is simply going to equal 1. So that is how my equation is going to look like. And now this is just simple algebra. I just have to move things around. So I'm going to have x plus 2 is going to equal 2 multiplied by x minus 10, or basically this is going to equal to x minus 20. And I'm going to rearrange that. I'm going to write that x is going to equal. So basically what I did is I move x to the other side, and I'm going to have to move negative 20 to the other side. So x is going to take a value of 2 plus 20. So that is going to equal 22. So basically my value of x is going to equal 22 for the equation to be true. So that is my solution. So x equals 22. So that is going to be for B. So basically what I did is first, so I have two different terms. I have make sure that they have the same base. So that is the case for this one. And then I simplify them. So instead of like having three separate terms, I simplify into one log term, right? I used the log properties, and then what I did is I changed that into index form. Then only I am able to find the value of x. So let's have a look at the C, example C. So here I have a index form. So 7 to the power of x plus 1, that is going to equal 12. Okay, so what happened for this case is that here my x is the power. So I wanted to find x, and x is actually the power. Okay, so how do I bring down the power? So the way for me to bring down the power, if I can actually make it in terms of log, and I can actually bring that to the front, right? So the idea is going to be this. So if I have log of 7 to the power of x plus 1, I can actually bring that to the front, and this is going to be x plus 1 log of 7. So that is what I wanted to do, so that I can actually have x by itself. So instead of like being a power of the 7. So therefore what I'm going to do is, so the thing is that this is an equation. So when we talk about equation, whatever that you did on the left hand side, you have to do the same on the right hand side as well. So what I'm going to do is I'm going to log both sides of the equation. So it doesn't matter. For this case, you can use a log to the base of 10, or you can also use log to the base of e, which is going to be ln. So either way, whether you decide to use log 10 or ln, so they're going to give you exactly the same answer. Or even if you use log 2, log 3, so the reason we actually use log 10 or log e, because these values are in your calculator, so that's the reason. But actually, if your calculator has other bases, like it has log to the base of 2, log to the base of 3, so you can also use them. However, because most calculators don't have that, so we're going to stick to log to the base of 10 and also log to the base of e. Okay, now I'm going to log both sides of the equation. So for example, let's say for this case, I'm going to use log of 10. So I'm going to have log of 7x to the power of 1. So that is going to equal log of 12. Right? So now according to the log property, so if I have a power and it's a log form, I can bring that to the front. So that is what I wanted to achieve. So I'm going to have x plus 1, so log of 7, that is going to equal log of 12. And the good news is that, so if you notice over here, so there's no x over here. Both of them are in terms of numbers. If you press your calculator, you can find the value of log of 12. And even if you press your calculator, you can also find the value for log of 7. So that's why here I'm going to write that. So x is actually going to equal log of 12 over log of 7 minus 1. And please verify this. Use your calculator. Sorry, it's not supposed to be ln, it's log, isn't it? So this is log. Sorry about that. I thought I'm using ln. But if you use ln, it's also going to give you the same answer. So no problem whether you're going to use log 10 or log e. Right, so when you use your calculator over this, so you will get x is going to equal 0.277. Okay, so usually that when you have decimal places, take 3 or 4 decimal places. So that will be enough. Don't take too many. Okay, and for this case, I have solved C. So I obtained that x is going to equal 0.277. So the idea is that whenever your function is in terms of index and what you wanted to solve is at the top, you log both sides of the equation so that we can actually bring down the x as instead of become the power. So now it's going to be at the front and it become x plus 1. So that will be the idea for C. Okay, so next I'm going to have a look at D, but again, so D is also going to be a similar idea. Okay, however, before I start with D, I'm going to simplify this a bit. If you notice, this is a constant, this one is exponential. So I'm going to bring this to the other side, so it's going to make our calculation easier. I'm going to write that exponential x is going to equal 19 over 3. And of course, for this case, this is my x. I'm going to have to bring it down. So what I'm going to do is I'm going to log both sides of the equation. Okay, for this case, you have no choice. Like you have a log to the base of 10 or ln to the base of e, but because we have exponential right here, you have no other choice, but you have to use log to the base of e. Remember, when you wanted to cancel the exponential, you need log also with the same base. So that is why for this case, I'm going to log both sides of the equation, but it will be log to the base of e, which is ln. So I'm going to have ln exponential of x log, and on this side is going to be log of 19 over 3. So that's how the equation looks like. And the same idea applies. Remember that log and exponential, they are actually going to cancel each other. And so I'm going to end up with x. Or you can also think about it as, so the x is going to go to the front. So therefore here I'll end up with x log of e. And that is going to equal log of 19 over 3. But we know that, so when you have log of 3, this is actually log e. And we know that log e, so this is simply going to equal 1. So that's why the equation is simply going to be x is going to equal log of 19 over 3. And log of 19 over 3 is something that you can use your calculator to calculate. And your calculator is supposed to give you what value? So I don't have my calculator with me, so please calculate this. So what is going to be log 19 over 3? Okay, so that will be the idea for D. So it's the same as C, but now remember, because we wanted to cancel the exponential, so you have to use ln instead of log 10. If you use log 10, it wouldn't cancel. Okay, so whenever you see E, so if you want to get rid of that, all you can do is take it to the log to the base of e. And number 5, so number 5, is it the last one? No, I still have another 2 remaining. So this is going to be more like an index equation. So I have 25 to the power of x plus 2 equal 5 to the power of 3x minus 4. So what happened is that I have 2 numbers over here. So I have 2 bases. So one is 25 and the other one is indexed with a base of 5. So the first thing that you should ask yourself is there any relation between these two? And of course there's a relationship, because we know that 25 is actually 5 raised to the power of 2. So this can actually be written as 5 to the power of 2x plus 2, and that is going to equal 5 to the power of 3x minus 4. And if you have a bracket like this, so what happened to the power? You multiply them, it become a product. So this is an index property that states that if you have a to the power of b raised to the power of c, so this is going to be ab multiplied by c. Okay, so that is why when I simplify this, I'll end up with 5 to the power of 2x plus 4, and that is going to equal 5 to the power of 3x minus 4. And if you remember the assumption that we have seen before, so this is what I'm going to use. If b to the power of m is equal to b to the power of n, then these two are going to be equivalent. Right, so this is what happened over here. So the base is the same. Okay, this is an equation, so I can simply compare the power. I'm going to simply compare both of this, and then I will get the value of x. So I will get 2x plus 4 is going to equal 3x minus 4. Now let's rearrange this. So bring x to the other side, bring this to the other side as well. So I'll have x is going to equal 4 plus 4, that is going to equal an 8. So my value for this case, in order to satisfy this equation, so my value of x, it should be equal 8. So that will be for e. And the last one, okay, the last one is going to be log. Okay, and I have a constant 2, so multiply by the 2 log terms. So what I'm going to do is, I'm going to bring the 2 to the other side. I'm going to write that this is going to equal log of 9x plus log of x9. That is going to equal 5 over 2. Okay, so now it looks less complicated than what it used to be. Alright, so however, before we started doing the operation and find what is going to be the value of x, I would like you to notice the fact that for this one, we cannot do the operation right away. I cannot simply use the property right away and put the log 2 together, because they are both of different bases. Like the first term has a base of 9, so the second term have a base of x. Okay, so what I'm going to do is, I'm going to have to make the base the same, then only I can apply the other law of logarithms. Okay, my suggestion is that actually it doesn't matter. You can use base of x, you can make it log of x, or you can also use log of 9. Okay, however, my suggestion is that in our calculation, it would have been easier if the the variable doesn't become the base. So actually you can use either one of them, but from my experience, it's going to be easier if you pick the base as the number instead of the variable. So that's why for this case, when I show you this example, so I'm going to change them into log of base 9. However, you can do the calculation but make it into base of x, so you will get exactly the same answer. Okay, so now which one do we need to change? So it's going to be this one. I'm going to make it into base of 9. So according to the property that we have seen before, if I have a log of AB and I want it to change it to be in term of base of C, so I'll have 2 log with the base of C. B is going to go at the top, A is going to be at the bottom. So that is what happened for the second term right here. So I'm going to have log of 9x plus, so this is going to be log of 9. 9 goes at the top, and at the bottom I'm going to have log of 9x, and this is going to equal 5 over 2. I don't know why, like every single time I write 5, they're going to look like 6. So let me not confuse you guys and put this as 5 over 2. Right? So that's how my equation is going to look like. And of course I can simplify this because we know that log of 9, so that is simply going to equal 1. So when I write it, it's going to become like this. I'm going to have log of 9x plus 1 over log of 9x. That is going to equal 5 over 2. I definitely need another page for this. Okay, when you come across something like this, what would you have to do? If you notice, like, this become very complicated. So I have one term at the top over here, and the same term actually become a fraction. It become 1 over the same term. Okay, so when you come across something like this, what you're going to do is you're going to use let u. So what I'm going to do with the function is that I'm going to let, it doesn't matter, you can use any variable. You can use u, you can use y, as long as it's not x. For example, let me put let u. So let u equal log of 9x. So instead of like having this very complicated term, I'm going to let it into as a very simple function, which is going to be u for this case. So let me do calculation on this side so we can compare them. So for this case, I'm going to have u plus 1 over u. That is going to equal 5 over 2. So what I'm going to do with this equation is that in order to simplify them, I'm going to multiply the whole equation by u because I wanted to get rid of the fact that u is at the bottom. So now when I multiplied all the terms by u, I'll end up with a quadratic equation of u squared, and then this is going to be plus 1, and on this side is going to become 5 over 2u. And let's rearrange them. So this is just a quadratic equation, so it's actually u squared minus 5 over 2u plus 1, and this is going to equal 0. Okay, like you have seen this before when you have a quadratic equation, so you can find the roots, and because this is to the power of 2, so there will be 2 roots to the of value of u, and the roots you can use the calculator to find roots. Okay, for this case you will get 2 value. So I've calculated that before. So what is going to be the value? So you will get that u is going to equal 1 over 2. And then you will also get u is equal 2. So those are going to be the value of u by finding the roots by using the calculator. Okay, however, let me remind you that u is not our solution. So when we solve this equation, what we wanted is we need to find what is going to be the value of x, because x is our original equation. So that is why, so based on this value of u, so we are going to find the value of x. How? So this is the equation that we're going to apply, right? So that is why I told you before. So this finding the value of x from u is going to be easier when your base is a number. If your base is a variable, so it could get like slightly more complicated. Right, so let me start with the first value. So for which u is going to equal a half. So when I substitute into the equation, so I will get that log of 9x is going to equal a half. So remember, so we wanted to find the value of x, so change this to index form. So x is going to equal 9 to the power of 1 over 2. And we know that, so this is equivalent to square root of 9. So x, the value is going to equal 3. So that is our first value of x. Okay, and then the second value of u is, it could also be a value of 2, right? So I'm going to have log of 9x. So that is going to equal a 2. So again, so we change this to index form. So x is going to equal 9 to the power of 2. So that is going to equal 81. So when you come across something that looks like this, so you have a quadratic equation. So the solution will be 2. Okay, so I end up with 2 value of x as well. So first is x equal 3, and the other one is x equal 81. Okay, so that is going to be a possible type of equation as well. Right, so I have actually prepared you a bunch of exercise right here that yeah, I actually put them together. This is actually exercise for the previous topic, 3.4. So you can do them together. Okay, so give them a go. The solution is already here. And then for topic 3.6, so we will discuss this together in class.